Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Noorilyana binti Abu Bakar. I'm from Polytechnic Ibrahim Sultan, Pasir Gudang, Johor, Malaysia. My study is about the optimization of mixing process for sweet soybean sauce using Taguchi method. The outline of the presentation starts with the introductions. Second, we go through to the methodology. Third, we're going to see the existing process capability, and then the optimization of mixing process parameter, and lastly the conclusion. First, the introductions. This study was based on the sweet soy sauce bean. So in Asian cuisine, frequently we use soy sauce as a condiment. The ingredients and the method used to create soy sauce must adhere to regulations and meet criteria to maintain its exquisite and unusual flavor and scent. So there are a variety of bricks will be focused on investigating the shortcomings in following the procedure of mixing the ingredient in the mixing process in order to get the level of sugar within their specification limit. Okay, this is the flow of the manufacturing process to produce soy sauce. We are starting from the soaking process, 4 to 18 hours, and then the soybean will be steaming, and then mixture with the several ingredients, and then there are mixing with the koji and the salt water for fermentations, and lastly we are producing the variety of soy sauce, whether salty or sweet soy sauce. Okay, as we can see, the figure shows the soy sauce with the wheat aspergillus sojae cultures to brew the soy sauce. So there are part of process to produce soy sauce, which is a fermentation process. Okay, it involves the fermentation, extraction, sterilization, homogenization, bottling, labeling, and packaging. So fermentation is a metabolic process that produces chemical changes in organic substrates through the action of enzymes. After fermentation, the paste is pressed as extraction to separate the solid waste and the liquid. Sterilization through heating for killing or inactivation of microorganisms is a must. And then homogenization, a free mechanical process that involves the subdivisions of particles or droplets into micron size to create a stable dispersion. So the process that we are focusing is the mixing process. Alright, this is a variation in soy sauce and the problem. Okay, quality of soy sauce, there are many variations in market. So it's dependent on the method and the duration of fermentations and the ratios of fermented soy sauce, sugar, caramel, and others addition to the ingredients. So the mixing ratio among the ingredients are critical to ensure that the resulted brix value conform to the specifications. So in this case study company, the company was facing high variability where trial and error approach was used to balance among the ingredients. Additional soy water was added if it was too sweet until the standard specification achieved. Not systematic, time consuming, and resulted in inconsistency. So limited study available in the literature on the optimization of soybean sauce mixing parameters in Taguchi methods. The objective of the study is to reduce the mixing process variability by applying Taguchi method to search the optimum parameter setting. For the scope, other parameters such as temperature, are not investigated in the study, then the study was limited to the ingredient of mixing process. Alright, this is the methodology. We'll study the current process and then we identify the process parameter. We optimize the ingredient by using Taguchi method for orthogonal array L8 2 times 3, and then we analyze the result by ANOVA and interaction plot by Minitab 21, and last we are using the confirmation run and compared with the mathematical model. Okay, next, the existing process capability. The company specification is 63 to 65 bricks, but we can see here with the histogram shows that normal distributions are shifted to be outside the specification limit. So this plot shows that a need for improvement by reducing the variability in the mixing process and adjust the process setting to be closer to the target. The optimization of mixing process parameter. So in the mixing process, there are two groups of ingredients, which is soy water and sugar, MSG, and caramel. Okay, we are using a lab scale experiments. We run 2 levels with 3 factors with L8 of orthogonal array with 8 numbers of experiments. The brix reading will be measured by refractometer in brix, and each experiment was run 3 times to enhance the outcomes. Okay, these are the sample of ingredients for experiments, and then this is the refractometer. Then this is the mixing in lab scale using overhead stirrer. Table 1 show the factor and their level, which is sugar for level 1 is 455 grams, height for 655 grams, MSG for 68 grams and height for 80 grams, caramel for 220 grams and for height is 320 grams. Okay, by using Minitab 21, there is the metric that we are using to form the experiment and read the brix for each ingredients. Alright, for experiment, each experiment we conducted 3 times, and then this is the average of brix. Okay, based on Minitab, this is the SN ratio. So the height value of SN ratio signifies the height value of the desired signal. Then the undesired effect of noise. So based on this result, it shows that height ratio is sugar. Okay, next we analyze the main effect plot. There are 2 plots here, which is for means and for SN ratios. So we can see clearly that the minimum value of the mean and the maximum value of SN ratios is observed. So ratios the same level, which is the significant value is 1 for sugar, 2 for MSG and 1 for caramel. So this level of control factor present optimal setting for optimization brix value. Okay, by ANOVA table shows that clearly that sugar has a significant contribution, which is 73.30% on brix value during mixing process, while MSG and caramel has less significant, with contribution only 7.33% and 0.54% on brix value. By regression model, brix equal to 63.55 plus 0.06 sugar minus 0.036 MSG plus 0.00117 caramel. So if we substitute the numbering with the regression model, so the equation will equal to 64.04, which is still in the specification limit. Okay, to confirm the result, so we run the 3 confirmation run with the optimizations of ingredient, which is sugar is 1, caramel is 2, MSG is 1, and then we have 3 reading of brix. Okay, we compare with the mathematical predictor, then we have the percentage of error, which is less than 1%. Confirmation run 1 is 0.4, confirmation run 2 0.25%, and lastly 0.22%. Okay, the conclusion, based on the study, the objective has been achieved. The DOE Taguchi method is very powerful and known technique for analyzing experimental data. So in this paper, DOE Taguchi method optimization of mixing parameter is done for best setting of brix value. So the result shows that sugar is the rank 1 with low value for 455 grams times 2000 kilograms. Monosodium glutamate is 80 gram for times 2000 kilograms, and caramel is 220 gram times 1000 kilogram. Okay, this parameter produce a brix value of 64.04 brix, which is in company specification limits. ANOVA result shows that sugar is the major contributing, which is 73.30% factor on brix readings. The confirmation experiment confirmed that the error occurred within less than 1% between equation and actual value. And Taguchi gives systematic simple approach and efficient method to optimize the ingredient to produce sweet soybean sauce in this case. Okay, that's all for me. Thank you everyone. Assalamualaikum.